Okay, so very good day to everyone. So today we'll be taking a look at a question on application of integration. So in this question, you're given an equation of a curve and equation of a line y equal to 5. And this line will intersect the curve at the points A and B. And first part of the question, you are supposed to find the exact x coordinates of the points of A and B. So we have y equal to 5e to the power x over square root 4e to the power x minus 3, y equal to 5. So to find the x coordinate, probably I will just treat this like a pair of simultaneous equation, equate them together and try to solve for x. So 5e to the power x over square root 4e to the power x minus 3 equal to 5. So this 5 can be cancelled away. I'll multiply this square root over to the other side. I'll get e to the power x equal to square root 4e x minus 3. I will square both sides, so e to the power 2x equal to 4e to the power x minus 3. And I will shift everything to the left. I will end up with this equation here, which looks like a quadratic equation, which I can just do a simple factorization. So I'll get e to the power x minus 1, e to the power x minus 3 equal to 0. So we can just solve them separately. So e to the power x minus 1 equal to 0. So e to the power x equal to 1. Taking log on both sides, I'll be able to get x equal to 0 because log 1 will just give me 0. And this will be my point A. And for this, I will just have e to the power x minus 3 equal to 0. So e to the power x equal to 3. Taking log on both sides, I'll end up with this. This will be my point B. So part 2 of the question says, use the substitution of u equal to e to the power x. Find the exact volume generated when the area bounded by the curve and the line y equal to 5 is rotated about the x-axis. And you're supposed to give your answer in this exact form, where A and B are to be determined. So when we are approaching this type of question, I think we cannot do this type of question without using a diagram. So I will just do a quick sketch here. And when we are using GC, I should be able to plot out this curve that looks something like this. So this will be my equation of the curve. And when we do y equal to 5, I should be able to get something like this. And it seems like they will intersect at the y-axis. I think we can just do a very quick verification because when x equal to 0 here, when you sub in x equal to 0, you should be able to get the point 0, 5. So it happens to be the y-intercept here. So here I will be able to get 0, 5 as my point A. At this point, it will be my point B, which I have found earlier on, which is my x equal to ln 3. So the region bounded by these two will just be this portion here. So basically, to find the volume of this region, I will be using the upper curve minus the lower curve. But usually when there is a sketch involving lines, when we are finding area of volume, usually it's slightly faster if we make use of the standard geometric shape equations. Something like the volume of the cone, volume of a cylinder, area of the triangle, and area of the rectangle, and so on and so forth. So for this case, I perhaps will be using the volume of a cylinder. Because when you have a line, when it's rotated about x-axis, you will actually get a volume of a cylinder. So I'll be using the volume of the cylinder minus away the volume generated by the curve. So we will be able to get this required region here. So let me just write it down here. So for volume required, it will just be pi r square h, which is the volume of the cylinder minus away the volume underneath the curve, which is given by the equation pi integrate y square with the limits at 0 and ln 3. 0 and ln 3. Okay, so let's sub in the values. So for the radius of the cone, when this one is rotated about x-axis, this will be the radius, and this will be the height. So radius will be 5, height will just be ln 3, and this y I will just replace with the equation of the curve. So I'll end up with 5e to the power x over square root 4e to the power x minus 3 whole thing square. All right, and this question actually gives you a guidance saying that you are try to be using the substitution u equal to e to the power x. So u equal to e to the power x. So our objective is to replace all the x away that we see, this, and also the limits, right? Because by default, this limits is in terms of x equal to 0, x equal to ln 3. So the first thing I want to look at is maybe I will try to replace away the dx. So I will just do a differentiation respect to x to get a relation between du and dx. So I'll get du over dx equal to e to the power x. And dx will be equal to 1 over e to the power x du. All right, but this expression here is considered as mathematically illogical, but I will actually prefer to use it because I can see you can just simply replace away the dx. So this case, maybe I can just suggest you can write it down, but write in pencil. Later after you do the replacement, just erase it away. Right, let's handle our limits now. So when x equal to 0, I sub in here, I'll get u equal to 1. So when x equal to ln 3, when I sub in here, I get u equal to e to the power ln 3, which will give me just 3. Right, so let's do the replacement now. So I got here, I've got 25 pi ln 3. So here, when I do replacement, is 1, 3. Square both sides, I will get, or maybe I just replace first. So I get 5u square root 4u minus 3 whole thing square. This will just be this. 1 over e to the power x, e to the power x just u, so I get 1 over u du. Okay, simplify a bit. I will be able to get square both sides first, so I will get u square minus u will just be u. So I'll get 25u. And this will give me 4u minus 3 du. Right, I think all the difficult parts have been done. So basically what we need to do is just to integrate this, put in the values, simplify it. Hopefully we'll be able to get this expression here. All right, but however I look at this, right, this is an improper fraction. So improper fraction, we can't integrate it directly. So what we need to do is just to do a long division first, change it into proper, then we do the integration. 25 pi ln 3. So maybe I can just factorize out the 25 first. So I got 25 pi. So when I do a long division for this, I'll be able to get 1/4 plus 3/4 over 4u minus 3 du. Okay, so now we integrate it. I will be able to get this 25 pi 1/4 u minus 3/4 1/4 ln mod 4u minus 3 mod 1 to 3. Okay, so let me just put in the limits. So when x equal to 3, so I get 25 pi, let me just 25 pi ln 3 minus 25 pi. So put in 3, I'll get 3/4 minus put in 3 here. This is actually 3 over 16. So 3 over 16 ln. Put 3 inside here, you will be ln 9. Then when you put 1 inside here, you get minus 1/4. Okay, sorry, I just need to change this a bit. Realize this is a plus, so it is a plus. So this is a plus. Okay, so from here, when you put in 1, right, it happens that this one is a ln 1. Ln 1 is just equal to 0, so the entire expression here is gone. Right, so I don't need to include it. So here I will get 25 pi ln 3 minus 25 pi. And here 3/4 minus 1/4 give me just half. So I got half. And for this particular case, I think maybe I can just do a ln 3 square. Because if I look at my final expression, there's a ln 3. So maybe I can kind of like force out a ln 3 here. So I will get a 3 over 16 ln 3 square. Okay, so this square I can bring it down. So I'll get 25 pi ln 3 minus 25 pi half plus 3 over 8 ln 3. Okay, so factorizing out the 25 pi, so I will left with ln 3 minus half minus 3 over 8 ln 3. So here I will get ln 3 minus 3 over 8 ln 3 will give me 5 over 8 ln 3 minus half. So the final expression they want is 25 pi over 8. So I will just factorize out 1 over 8 from here. So I got 25 pi over 8. So I just left with 5 ln 3 minus 4. Okay, which is good because this is the form that I want to have. So by doing a bit of comparison, I can just see that A will be equal to 5 and my B will just be equal to 4. Right, so this will be my final answer for this question.